How are you doing for sound, guys? Just checking. Evening Turbo. Yeah, I did something really silly today. Ended up going to Costco. Spent half the day there. Just friggin' exhausted, man. I don't even know how people do this. Well, I just realized that watching the movie, we completely forgot about John Wick 2. So we started. I couldn't remember what happened in John Wick 2, so I started watching that, and then I think um, embarrassed to say that I didn't actually finish the movie. I just fell asleep on the couch. Yeah. On a complete another note, it wasn't really my wife. It was just like I actually wanted to watch a movie with her because I haven't actually spent much time with her, and yeah, so I just felt kind of guilty just doing a tutorial while she was waiting for me. So anyway, one more night of this, and then yeah, just some sort of normality returns in our household. Anyway, guys, we're just waiting for a few more people. We're still gonna just kind of power through the. I think I might do three more excellence questions, and then like we'll maybe just do a couple of tips and tricks. I don't think there's any tips and tricks really. I mean, ultimately, whatever exam question comes on the day, that's the one you guys got to go with. So I wish I could predict what the questions are, but really, I can't really do any of those things. So the usual. Let's start off with a complex number question. Pick a year, and we'll actually go through it. Trying to think. I think we finished all of 2016 ones and 2015 ones as well. Inferno, that's correct. If you get a T mark, that's E7 minimum. I've never actually read this document. Profiles of expected performance. Don't know what that is. I always see that, right, but I've never actually read through it. No, it's all the documents. Yeah, I don't know. I don't know, Andrew. I've never actually fully worked through that, so. Jovan, yeah, I know what you mean by it's one of those things where you just go. Sometimes I can do 24 like just like that, but then sometimes you get one of those questions where you just go, what is happening here? I'd agree with Pyro Shark there, Charlotte. Yeah. All right. So, which year are we going at, guys? So we go right back, or can you do 2013 Q1E? That's differentiation, so we'll do that next. Then we'll do an integration to finish off as well. Complex 2016, I think I did all the questions, guys. Let me have a look at it. Yeah, we did the straight line one, which was a locus one. We did the equal roots one, and I think we did all of 2016 ones in the last week, guys. So we're gonna skip 2016. Let's go to 2015. My guess is I think we also did 2015, all of them. I could be wrong. Yeah, we did this. This one was a nice one to work through. I think we also did this. 2015. Yeah, we didn't actually do this one here, which was complex roots. 2089. Okay, let's go have a look at 20. I don't think we did any from 2013. No complex numbers from 2013. It's funny you should say that, Ikamjeet. Like, I was just looking at how to watch this one here. I was just trying to figure out. I didn't realize that it was actually on Prime, so I've got to figure out how I can get Prime sorted for maybe a month to try and watch it. Okay, so what we're gonna do is, yeah, 2013. So let's pick 2013. We either get question 1E, or we've got question 2E, which is a locus question, or we've got a roots question. So which one do you guys want to actually do? I appreciate the, well, it's a banana. Yeah, thanks, man. 2013 2E. All right, let's go 2013 2E, which is the locus question here. Is it locus question? Yeah, it kind of is. So let's have a crack at this question here, guys. That's going to be complex numbers 2013. So this is one of those questions that we were talking about yesterday, right? Like, this is a combination question, so they've actually got locus and one of those proof, like purely imaginary kind of questions, right? So nothing changes here, guys. We're going to put z is equal to x plus iy and kind of like work through it there. But in this question, it's actually asking you to describe fully the locus, which generally means that you might be ending up with I don't know, like a circle or an ellipse or whatever the shape is. You're just going to end up getting you have to describe the graph, like whatever the equation you get. You can't just stop at the final equation. You actually have to just kind of describe what the equation is. So I'm going to give you guys maybe like a few minutes to kind of have a go at this question. And if you're not sure what to do, then yeah, make sure you put z equals to x plus iy and then kind of start working away at it. And yeah, let's see how it goes. So I'll give you guys maybe 3 minutes, right? 7:41, I'll go through the answer. That should be plenty of time there for you guys to kind of go through. Stephen, I'm only doing like past exam questions, man. Like, so yeah, if there is a differential equation and integration, we can do that one. Or if you find a particular question pre-2015, then tell us what it is, and then I'll try and do it. But yeah, like I said, like made the mistake of going to Costco today. That was a very bad idea because tired, Jacob. I'm tired. You know, like standing 6 hours it's never good for doing groceries for 6 hours. Usually I do it in like 45 minutes. Hector, I've already done that question and I think the video is already up. Calc options. What are calc options? Oh, you mean these ones? Okay, I think what I generally tend to use this, I use the integral function just for like calculating area under the curve between 2 points. Like, it's just a quick way of checking whether your answer is correct or wrong. I never use this one here. I never use d of dx or d squared dx squared. I hardly use it. But the integral one is quite handy because you can integrate your, as long as you show the integrals, but the rest of the part you do it in the calculator, kind of speeds up the process for you. Yeah, it's only for definite integrals. I mean, it doesn't actually really do anything else. So as long as you have like the two values, the lower limit and the upper limit, then it kind of does that automatically for you. So if I want to find integral of x between, what do you call it, if I have it between, for x between 0 and 5, I would actually put it like this. So 0, 5. And that's going to give me, the answer is 12.5. That's all. That's all it does. You should have got Sky. Yeah, you're on the right thing there. So you should say that it's actually a circle and it has a radius of 2 and it's centered at 0, 0. To get to this, what you do is you click on option. When you click on option, you're going to get like list, mat, complex, calc. So just go on calc and then you click on integral and then you're good to go. All right, guys, I'm going to go through this question here now. So what we've got here is we've actually got, so we're going to put down z is equal to x plus iy. So then I've got x plus iy plus 2i divided by x plus iy minus 2y. Aryan, to answer that question, it depends. Like, I mean, if you're using like in differentiation, if you're dealing with pi, then you most likely want to make sure that your calculator is in radians. If you're using degrees, then you want to make sure that your calculator is in degrees. And I think you've got to be, you kind of have to, like, I wouldn't call it a minor error because I think it's a major error, because by level 3 you should know when you should be using radians. Like if you have pi in one of your things, you actually have to make sure that you are using radians, right? This is 2013 question 2E complex. Cool. So the next thing what we're going to do is we're going to have our like terms. Well, I'm going to put my real terms really. So I'm going to put that as x plus y plus 2i divided by x plus y minus 2i. Now I need to multiply by the conjugate of this. So it's going to be x minus y minus 2i. And also in the numerator, I've got x minus y minus 2i. Just double checking that I'm actually on the right track there. Yes, I am. So the next part is I've got to actually expand this ugly looking bracket. I mean, I should have actually left it as that, but it's all right. So I've got x squared in the numerator, and then I've got minus x y minus 2i. Then I've got plus x y plus 2i. And then I've got minus y plus 2 y minus 2 I squared. All of that is divided by x squared minus y minus 2 squared I squared. So with that in mind, what I've got to do is I've got to kind of simplify the numerator. The denominator, I don't have to worry too much about it, because remember we talked about this yesterday. You know, when you're trying to do pure real, if something is purely real, then you're looking at the numerator where without the i's into it, and if it's purely imaginary, then your real part is actually equal to 0. All right, so all you got to do is you just got to figure out which part is real in the numerator, put that equal to 0, and you pretty much should be on your way there. So now let's see. I don't know, man. I think I can be purely lazy in this, right? I'm just trying to kind of see whether this would actually work or not. Plus 4xi. Where did the xi come from? So hang on. Let me just have a quick look at this. I'm trying to be a bit lazy here by not actually expanding the whole thing, because I know in the answer schedule they actually expanded the whole thing, but reality is you don't actually need to expand the whole thing. Why? Let me just show you guys why. The first thing I'm going to do is I want to actually convert this I squared here, which is going to be -1. So -1 times -1 is going to be positive. So this will become plus, I've got y plus 2, y minus 2. And then what I'm going to do is I'm going to put all the imaginary numbers on the left-hand side, right? So my imaginary number is all this right now. So I've got minus x, y minus 2i, plus x, y plus 2i. All right, and that's all now divided by x squared minus y minus 2 squared. I squared is -1, so that means the denominator is going to be +1. But again, it doesn't matter, because if something is purely imaginary, then the real part is actually equal to 0. Now, I know that this part is actually the real part because this number here has an I in front of it, and this number here has an I in front of it. Because so those two numbers are actually the imaginary part. And because of that, like, I didn't even need to expand any of these things here. I'm just going to kind of take a shortcut here, and I'm going to say that the green part is real. So if something is purely imaginary, then real part is equal to 0. So what I have is x squared plus y plus 2, y minus 2 equals to 0. And then I've got x squared plus y squared minus 4 equals to 0. Rearranging this, I'm going to get x squared plus y squared is equal to +4. Now the center of the radius, remember the equation for radius. Now if you forget the equation for circle, then go into conics in your calculator. And if you go down to circle, there you go. You've got the equation of the circle right there. Now we've got x squared plus y squared equals r squared. Now we don't have an h because h is equal to 0, k is equal to 0, and r is equal to 2. Basically, the center of the circle is at 0, 0, and it has 2 is radius. And you can kind of say that locus is a circle. Armand, I think have a look at the 2019 paper, man. I've already worked through some of those questions. Emma, I know that a few years ago they did put ellipse like way back, right? Like way back. But then after that, they kind of realized that some of the kids were not doing conics. But if you do get to ellipse, right? Your ellipse equation is given here, but it's like to kind of not factorize it, what do you call it? To kind of like complete the square and put all of that, it's going to be a bit of a mission. Now, Tom, locus is one of the easiest ones, man. Like I think in the Mathdemic series, the final video is a locus one, and it's only 1 hour long. Trust me, you watch that, you're going to nail locus after that. Like it's all you do is you just get rid of z and replace it with x plus iy and rearrange. That's all you got to do. On the calculator for this one, if you go into menu, go into conics, all of your equations for your conics, like circles, parabolas, it's all there. All right, so if you do forget it, you can always go in there and actually pick up the formula from there. It's a bit of a pity because it's like, especially this one here, it's super useful for level 1s. I just completely kind of forgot about it. How do I know the center is 0, 0? So if you go to the circle equation, notice how it's x minus h squared plus y minus k. Now in my original equation, I only have x squared plus y squared, and because I don't have h or k, the center is going to be 0, 0. Ben, yeah, we don't worry about the denominator, right? Because the denominator, as long as the denominator is a real value, we don't really worry about it, because in this, if something is purely imaginary, we only look at the numerator of that value equals to 0, because 0 divided by any number is still 0. So that's why we kind of completely ignore the denominator. Raveen, I think we did that in one of the tutorials last year for that question. Hector, no, the h is like where the x value of the center of the circle is, and the k is where the center of the y coordinate of the center of the circle. Adi, I'm just looking at your question there. I'm not sure which question you're referring to. Boss C, unfortunately the 27 paper was actually done during one of the live tutorials. So it'll be in last year's integration live tutorials. Basically, I do sleep. It's square root of 4 is 2, so that's the radius squared. No, Ben, if it doesn't actually say describe fully the locus, then I don't think you need to do the last 2 bits. Like, you can stop at the equation itself. Lee, is he your calculus teacher? I know him, man. I know him. He's a good man. Right, guys, we're going to move to differentiation. One last differentiation question for the road, and then one final one for the integration one, and then I'm going to call it so we can all, you guys can kind of go on your own and kind of work through it. Uday, if it says purely real, then I would actually take the blue parts here and put that equal to 0. So this plus this is equal to 0 for purely real. Emma, I think 1 hour is more than enough for each paper, but my suggestion to you guys is this: like, you guys really need to get into this mindset of like, get all the easy questions out of the way. In fact, like, depending on what grade you're going for, right? If you're going for excellence, my suggestion is that start on the excellence question that you feel comfortable in. And after 10 minutes, if you're like, I don't know what I'm doing here, then go back and finish like, let's say you're attempting question 1E. 10 minutes in, you're like, I don't know what's happening. I can't figure this out. Then what I would do is I'd actually go spend some time on 1C and 1D to make sure I get those 6 points. All right, it's just to guarantee you getting that maximum points per question. And then I would attempt 2E, and again, after 10 minutes, if I'm having problem, I would go and finish 2C and 2D. And you kind of have to repeat that process, right? But yeah, like, my suggestion is like, spend the first 5 minutes just reading through the entire paper, like all 3 papers. Because there are some times when you look at a question and you need a bit of time for your brain to process in the background. So it's really important that you guys read all 3 papers questions right at the beginning. Even if you're not going to do them, just make sure you actually read through all the questions, all right? And then start kind of like strategizing as like, okay, which question am I confident in? Which one do I think I need more time in? The ones you're confident in, just go at it. And halfway through, if you get stuck, make sure you attempt those questions C and D off that question so that you can actually get a maximum of M6 grade. How many of Mr. Dahmer's kids are here? Leafy, nah, man, I don't think you will. Like the way the questions are actually set up, you will kind of go, right, I know I'm doing differentiation. Right, let's go to differentiation, and we're gonna go all the way back 2014. I think we did a few questions from 2014 for differentiation, and then after that we'll actually go to integration. This one we did last night. We've got this one here, which is a rate of change question, or we do one of these questions here, which is a volume question. Yeah, volume question it is. All right, let's do this one here. I'll take a shot of this. So guys, I'm going to give you guys one clue to get you started with this question is draw a front view of this three-dimensional shape, and it might be the clue that you might need. So I'm just going to draw this here for you guys. The front view of this. So that's pretty much my hint for you guys. And I'm going to give you guys a few minutes to kind of get that going, all right? Now, look, if you are stuck with this, remember, I'll also give you guys the volume equation, right? What is the volume of cylinder? Pi r squared h. So this is the volume of cylinder. This is differentiation. What did we say it was? 3E, was it? 2013? Or was it 2014? I think it might be 2014. Yeah, 2014. Oh, this was a stupid one. Where the Man, I don't think I'm gonna have time, man, because I want to do one more after this. I want to do an integration question, and then after that I want to call it, dude. Like, I just need to give you guys time to actually kind of work on your own, because h equals to 2r plus 40. I don't know why you're doing 2r plus 40 there, Aryan. That's interesting how now we got 40 over 3, which is 13.33. That's the radius. The radius is 13.33. Because I think the question's asking what must be the radius be. Ah, you did it that way, Alvin. But then it's a negative gradient, Alvin. It can't be positive if it's going that way. Well, I guess if you make it this way, it does go positive. I didn't see the negative there, Alvin. I thought it was, I just saw that as a 2. All right, so what we've got, what are we gonna do for this? I'm kind of like, see, you know, it's been one whole week of calculus when I start looking at things and I'm like, I start overcomplicating the questions. Like I'm actually like, what the hell am I doing with this question right now? So if that's R, that's 2R. Why would that work out? H is equal to 2R. What? How would that work out? But then you can't have a limit. You need a limit. Yeah, I guess that's the only way to do it. Like I was thinking about doing it slightly different, but what some people were talking about this. Look, just give me a yell out if you actually have another way of doing this, because you can create like a y-axis and an x-axis, right? And then this point here is 40. This is radius right now, which is on the r-axis. R is going to be the x-axis. H is going to be the y-axis, and this has a gradient of -2. So we could write that h is equal to -2r plus 40 as the gradient. Similar triangles, if you were to do similar triangles, we've got, if you've got similar triangles, you would probably do it this way. So let's have a look at similar triangles. You've got the little, sorry, let me just draw that again. So this part right here is now r. And this part right here, from here to here, is going to be 20 minus r. And if the h that we have is actually twice that, like, you know, because you've got 40 here over 20. So we can write this as 40 over 20 equals h over 20 minus r, which again is going to be 2h 20 minus r. 2 times 20 minus r equals to h. H is equal to 40 minus 2r. So either way that you do, you can use similar triangles, or you could use an equation of a straight line as well. you're going to get h is equal to 40 minus 2r. Once you do that, then the question is actually pretty straightforward, because all you have is pi r squared, 40, take away 2r, and then expand the bracket, so you're going to get 40 pi r squared minus 2 pi r cubed. Differentiation of that is going to be 80 pi r minus 6 pi r squared. So the maximum happens when it's equal to 0. So 0 equals 80 pi r minus 6 pi r squared. Take r out as r pi as a common factor. You're going to get 80 minus 6 r, and then r pi equals to 0, or 80 minus 6r equals to 0. So negative 6r equals to 80. R is equal to 80 divided by negative 6. Positive, sorry, that should be negative 80. My bad. And then negative 80 divided by negative 6, which actually equals to 40 over 3. So, lines. Let's do line number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. If you have any issues with any of the line numbers there, just give me a yell out, guys, and then I'll happily chat away. The r pi side turbo, we don't need to worry about it, because r pi equals to 0. It's going to give us r is equal to 0. If you have r equals to 0, you're not going to get any. That gives you your minimum volume, which actually is equal to 0, while r equals to 40 over 3 gives you the maximum volume. Because remember, when you're working with a cubic, you're going to have a local max and a local minimum. So basically, I do sleep. Line 2, I basically did this. I had 40 divided, like it's similar triangles if you think about it like this. So this part here, and so all I've done is like just put thanks Ryan, appreciate it, man. Yeah, so it's just similar triangles. I think if you've been working with similar triangles, you could pick any one of them, and as long as you put them as a fraction equal to another fraction, you're pretty much good to go. So sometimes you might have actually done it like this: h over 40 equals 20 minus r divided by 20. That's one way of doing it. Or you might decide 40 divided by h equals 20 divided by 20 minus r. There's just so many ways of doing similar triangles. All you have to do is match up the sides, and then you should be able to good to go. You should be good to go. All right. Or as Turbo said, you could convert it to a x and y, kind of put a Cartesian plane through it, put origin somewhere, and figure out the equation of a straight line, and then work through with that as well. Which line gets you merit in this? Merit is actually a correct expression for dVdr. So we're looking at merit right here. Line 8 is merit. No, not at all. The cone wouldn't matter in this case at all. It's just the inside shape that we're always trying to figure out. Bulksy, I just looked at 40 over 20, so rise over run, right? Like that's how I got -2. Because the -2 is basically rises -40, not rise, drop, and then divided by x, which is 20. Kings, was a question like this in 2020, but you had to prove pi meter cubes, so you actually had to use second derivative. Ah, right. I can't remember that one. Newbie, yes. Galactic NZ, the biggest I've had is about 893 2 years ago. That was 893 on the stream, which was a bit mental, to be able to say. Charlotte, the H equation, it's like you've got multiple ways of doing this. You could actually do like equation of a straight line. So if I take this right here, what you have is you've got your first coordinate, which is 0, 40, and your second coordinate, which is actually 20, 0. So that's basically these 2 points here. That's this point of the cone and the bottom point of the cone that actually match up. And if you look at it like this, so see how the pink line goes there? That's the pink line that actually goes from there to there. And you actually get equation of that line to get the height of the cylinder. Yeah, Turbo, pretty much. We use the outside shape to get the variables for the inside shape. Absolutely correct. Adash, like if you're like, trust me, man, like doing these excellence questions, like if you can still pick up like achieved grades from it. So I think like in this question, if you had the wrong expression for the volume and if you differentiate it correctly, you could still get an achieved for it. Yeah, Captain, that's always a good idea. I always change the 3D questions into like the front view of it, so I can look at it two-dimensionally and then put it on like an X or Y axis to make things a little bit easier for me. And I think it should pretty much work for most of them as well. Turbo, absolutely. Like for the excellence question, even if you make up like somewhat like like don't go completely random, right? But like if you somewhat come up with like some like a close enough equation, but if you can show them that okay, here's a wrong equation, but you actually know how to differentiate it, then you can. Yeah, you're right. It is a free achieved mark, to be honest. So just gotta like, that's why I keep telling people like that are aiming for achieve. I'm like, don't aim for achieve, like aim for merit or excellence, because just doing the differentiation for those questions should get you some achieved questions, achieved marks from it. Knowing them, Tom, you never know, mate. You never know. All right, guys, let's do the last question for the night, which is going to be an integration one. Skylar, I think this is the first time, like a lot of time I've done similar triangles, but this is the first time I've actually done this again with straight line equation. And I think straight line equation, putting it in a part of a straight line equation is a lot more, feels a lot more easier. But I think it'll get trickier when you try and do for like inside a circle. Like if you put that shape inside a sphere, it's slightly going to be different. All right, let's go to integration. How far did we go? Like, have we gone to 2014? No, we never did 2014 integration. Okay, so here's our 3 options for integration today for excellence questions. We've got area under the curve. We have, what is this? Now this ugly looking thing here, I remember talking to you guys about this yesterday. If you remember, when you get something as ugly as this, just read the question, substitute the values, and you're gonna be fine. And this is one of those questions where it looks ugly, but you'd be able to do it like within a few minutes. And just because it's integration, what I might do is, yeah, so we've got a couple of questions here. We've got another, what is this one? We got a differential equation one, possibly, and we have the ugly one, which is 2e. Yeah, like see, like look, this one here, I'm not going to do the whole question, but I just want to show you guys what you need to do in terms of solving this question, because I think it might be better we do the other question than this one here. So while this question looks really, really kind of like, whoa, what's happening here? But the reality is, all you have to do for this question is just substitute. So you just have to find the values and you're pretty much good to go, right? So let's have a look at this. First off, they give you they actually tell you this: find the coordinates x, y of the centroid of the shape, right? So your x is this one here, and your y is this one here. F of x, so notice how this is f of x and this is f of x. The f of x is actually given here. So, and then your b and a value is also given. So that's b and a, which is actually from 0 to 4, which again, they say it here. So while it looks complicated, all you really have to do is just substitute those things and solve, and you'll be fine, right? Yes, it looks complicated. Yes, it looks ugly. Yes, I've never done a question like this in my integration life, but all it is, it's just substituting those values and doing some of the basic integration. All right, and that's why, like, I'm going to tell you guys this right now. Like, I'll leave this question here. Like, maybe if you guys have a time, look at the answers, and you'll see what they're doing. All they're doing is just like very basic substitution there, and that's pretty much it for this question for an excellence. Yeah, f of x is the same thing as saying y, so it's just a function. That's all, you're just substituting in there. So literally what you're doing is you're doing this. X bar is now there's one other thing that you need to remember. Like, if you look at it, there's one more part that I've kind of missed out here, which is this part A. This A is actually area of the object, which is this area right here. So there's like 3 components to this question. First, you need to figure out what the A value is. To figure out the A value, that's between 4 and 0, square root of x plus 1 dx. Fairly straightforward. Then you got to work out your x, which is 1 over A, integral of 4, 0, x times square root of x. Sorry, I'm just kind of writing with this vertically, so it's a bit tricky. And then your y coordinate is going to be 1 over A between 4, 0. What do you got? F of x squared. So square root of x plus 1 squared over 2 dx. So, and that's basically it for this question, guys. You've got these 3 points, 3 things to calculate. You calculate the first one, which gives you the A value, which you could have actually done it in the graphics calculator as well. And then after that, you kind of just do that. This whole question, you can do it in the graphics calculator. So as long as you know how to integrate it, you pretty much use that function that I showed you guys in the main menu. So just go here, and you would actually go option, calc, and use that integral function. Uday, if you look at it, the red part, which is A, is the area of the object. So if you look at it, the area of the object is actually the part that's this part right here, which is area under the curve. So as much as it looks complicated, so if you get a complicated question like this, just read through it and figure out whether we could actually just substitute and solve, because that's most of the time that's all it is. I think I put it on stream settings is at low latency at the moment there, whoever was wondering about that. What do the coordinates mean? It's the coordinates of the centroid of the shape. So whatever that means, who cares? All we care about is figuring out the x bar and the y bar. So going back to the integration paper, we've got 2 choices now. We could work on this one here. Or we could work on the area between the two, kind of this kind of question here. Venus, it is different because it's like 3E looks like 3 is the one that's winning. Yeah, I'm gonna say the area between this one is also they're actually giving you guys the answer. They're actually saying the answer is 1/3. So you just have to prove that the answer is 1/3. So I reckon you guys can probably kind of mess around with it enough, and eventually you can get it. But like, let's go to that last question, which is 3. Where is it? 3E. All right, guys. So I'm gonna give you guys a few minutes just to have a crack at this. Like, have a go with what you can, and then we'll kind of I'll kind of work with it. But I don't think this is a. I thought it was an exponential question. Am I wrong? Or KT DH 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 KT? Oh, maybe it's not. By the way, for the previous question, you guys should have got an answer for x as 2.223 and then y as 1.214. Actually, no, this is not Newton's law of cooling, guys. This is just a normal question, but it's just a bit dragged out with the costs being in there. To be honest, this is like it's a messy one, but it's a lot easier than what it actually looks like. Roseanne, if you're doing that, I think it might be because you're putting in the values incorrectly. You might need to put like you always put the small number first and then the large number after that. Now this is not Newton's law of cooling, guys. This is just a normal cos graph. Looks like it, like normal cosine integration. Longest day of the next year. what have these guys been doing? I think it's like the longest day of the next year. So whatever the first longest day was, you're kind of looking at 365 after that, right? So what's the best way to study for this? It's like I still say, man, practice exams. Go through the practice exams like that. That's all I'm gonna say. Keep doing that. Basically, I do sleep. It's really interesting watching. I should show you some of the analytics of my channel when it comes to exam time. It's so obvious, like how you guys study. I've been studying your study patterns for nearly 6-7 years now, and it's almost every year it's the same pattern. It's just hilarious. Let me see if I can find the graph while you guys are finishing this off. Lifetime. Yeah, Venus. Yeah, exactly. This exactly a year between the two longest days. Um, by the way, check this out. This is what happens every year. You can kind of see the peaks. This is like MCAT exams, MCAT exams, MCAT exam, MCAT exam, MCAT exam, MCAT exam. This year it's just gone up like nuts at the moment. Just a lot more people using this. I do sometimes, but it's like, but the number of views only happens during. Now I think, Charlotte, maybe next year I'm going to change it up a bit, because a lot of people have been asking for mathematic calculus for level 2 and level 3 differentiation integration, so I might actually do it throughout the year. But anyway, look, let's get started with this question. I know it's getting late. I want to wrap it up so that you guys can actually go do your independent study as well. So we've got dH dt is, you can expand this, all right, if you want to, if it makes it easier for you. So you might actually say 12k plus 3k cos 2 pi t over 365. And yeah, it doesn't really matter like which way you do it, so I'm going to kind of do it this way here. So which means h now is going to be integral of that, which means I'm going to get 12kt plus 3k, and this is going to become sine 2 pi t over 365. But I've got to multiply, in this case, by, or you can actually say 1 over, because I'm integrating it, 1 over the differentiation of this. So this is going to become 2 pi over 365. Or in other words, what we can say is we can actually say h is equal to 12 kt plus 3 times 365k. What have I got? Sine 2 pi t over 365. And I've also got 2 pi in the denominator there. But of course, I need to remember to put the plus c in it. So once I do that, that's my initial correct integration, which actually gets you an achieved grade. The next part it says is that on the longest day of a particular year, a plant has 84 centimeters. So we are going to actually take that first longest day as t equals to 0. So longest day, we're going to say t is equal to 0 and the h is equal to 84. So we're going to substitute it in here. So we've got 84 equals 12k 0 plus 3 times 365k over 2 pi, and then sine of 2 pi times 0 over 365 plus c. And what you're going to get is 84. That's going to be 0. This is going to be 0. And c is equal to 84. The reason why we multiply by 365 over 2 pi is because in the previous line, we're actually doing divide, like we're multiplying by 1 over 2 pi over 365. So basically 365 comes to the numerator. The red part is basically just the differentiation of the function. Because remember that when you integrate something, you've got to divide by the differentiation of whatever's inside the bracket. All right, so in this case, I have to differentiate this particular thing to get to this part right here. No, not t squared over 2 banana swirl. It's actually I know this is the part people kind of get confused with, but if you think about it like this, if I integrate sine 2x, then this will, maybe not sine 2x, let's say cos 2x, for example. If I integrate cos 2x, I'm going to get sine 2x, but then I have to divide by the differentiation of whatever the bracket is. In this case, it's going to be 2. All right, and that's what I've done here. Done in this case, I've actually divided by the differentiation of whatever's inside the bracket, which is 2 pi over 365. Well, it's the same, Tom, it's the same thing as saying divided by. So if you want to divide, like say for example, in that sine 2x one that I just did, instead of dividing by 2, I could also do multiply by 1 over 2, and that's what I did here. It's one of the things about integration, guys. Integration, you always have to, when you integrate a function, it's kind of like you have to offset it, right? Because like if I differentiate sine 2x, right? If I differentiate sine 2x, I'm actually going to get cos 2x multiplied by 2, right? So this is, if y is equal to this, then y dash is equal to this. So if I actually have cos 2x and I want to integrate it, then I'm going to get sine 2x, but I have to divide by the differentiation of whatever's inside here, which is 2. And that's why I kind of need to always remember that, like when you integrate, you've got to actually divide by differentiation of whatever's inside the bracket. Cos squared x, Joshua, you have to use special cases for that. We talked about that in a couple of tutorials ago. We said that you have to convert that to a double angle to actually integrate. Otherwise, you can't just integrate cos squared x like that. So my equation for h is equal to 12kt plus 3 times 365 k over 2 pi sine of 2 pi t over 365 plus 84. Now it actually says that 75 days later, so t is equal to 75, h is equal to 91. Now we're going to use this to try and figure out what k is. No, Joshua, differentiating cos squared x, you use chain rule. So we're going to put down 91 is equal to 12k 75 plus 3 times 365k over 2 pi sine of 2 pi 75 over 365 plus 84. Super ugly equation. but I'm going to do that 91 minus 84, which is going to give me 7. So 7 is equal to all of this thing right here, which I need to kind of work out. I wonder if there's a quicker way of doing this, but looks like there isn't, but like I might have to just do it the long way, guys. Sorry about that. So 75 times 12 first. Oh, lovely. Forgot about this. It's going to be 900k. And then I've got all of these things here inside, which is just where do I do sine? Let's do the sine first. 75 times 2, 150 pi. So 150 pi. Now let's just do it originally. So we've got brackets 3 times 365 divided by 2 pi. That's that. Multiplied by sine of 150 pi divided by 365. Okay, which gives me 167.5k. So 7 is equal to 1067.5k. And I'm going to get k is equal to 7 divided by 1067.5. Whatever that is. Oh man, you guys got to give me some ugly numbers here to work with. 0.00 656. Keep spare ones, Charlotte. Keep spare ones. All right, guys. So we've got the k value, and then all they're asking now is what happens to it. What's the height of the plant after 365 days? So we're going to put down t is equal to 365, and we've got to figure out what h is. So h is equal to 12, k, which we already have, which is 0.0656 times 365 plus 3 times 365 times 0.00656 divided by 2 pi and multiplied by sine 2 pi 365 over 365. Now that part, now this is really interesting, right? Because we know that 365 over 365 will become 0, so sine of that will become 0. So all it is just the first part there that I need to work out. So I just need to go 12 times the answer times 365, and I'm hoping I'm on the right track here. No, I missed something else. Oh, plus 84. I forgot the plus 84. Yep, there we go. H is equal to 112.72. Now the reason I kind of completely skipped this entire thing in the pink box is because 365 divided by 365 is 1, and then sine of 2 pi is actually equal to 0, so that whole pink box is actually going to equal to 0. All right, what I'm going to do is for this question, I know there was I kind of went through it fairly quickly. I'll put up some numbers, and you guys can feel free to ask questions away. Step 0. Line 10, I just took out the 84 from here and I brought it across, and I just didn't write the rest of the equation down. Dean, I've already done all the 2021 papers, man. It's up on my channel, so have a look through that. Like, this question was a lot more substitution than integration. Now, integration was just like the line 2. That was the first part of integration. The rest of it was all just substituting the values, right? Line 9 to 11. Oh, that's just a rearranging one, man. Y integration f dash of x. Turbo, that one is just like you'll end up with just ln of the function itself. Flynn, that usually comes with practice, man. Like, look, you still got a bit of time. Like, you know, practicing a few of these questions right now is still gonna kind of help you out with it. Guys, I know. Look, I said 3 questions. I gotta wrap things up here because like I don't want to create more chaos here, but like well, not chaos, but like more like I think I'll let you guys kind of go from this point onwards. Yes, you do need some good sleep, especially for those guys that are doing 3 papers. Line 1 is just expanding the brackets there, Charlotte. That's all I did. Yeah, it's look, I know it is a bittersweet always. Like, for example, when I kind of come to the end of these level 3 streams, because it's weird because I haven't actually seen any of you guys in real life, but yet you know, we've kind of been working with each other for like 3 years. So thank you very much, CL13, appreciate that. But yeah, couple of things from me. What is it? The first thing is this, like, first thing I'm gonna say to you guys is make sure that you guys answer all the questions, all right? Like, especially at level 3, you do not want to leave anything empty. Don't leave anything empty. Make sure that you guys answer everything. That's number 1. Number 2, read all of the questions, all right? Don't leave, like, don't ever kind of go, I'm not gonna try and I'm not gonna read any of these questions. Like, read all the questions and then actually make a plan, like how you're gonna approach the questions. Like, okay, which one is gonna make you feel confident? Like, always, like, if you see an easy question, just go for it. Just do it straight away. Get it out of the way, all right? And yeah, that's pretty much it from me, guys. Like, all the best. Like, some of you I might never hear from, and I know that I was actually telling my wife the other day, every year, like, there's a massive drop in subscribers, because it's like, you know, I kind of spent like 3 years with you guys, and then after that y'all unsubscribe, because, you know, that's completely understandable. You guys go, and then it's always a little bit it is a bit emotional, I have to say. It is a bit emotional because, like, all of you guys I just know by the names, and then yeah, it's you guys yeah, you guys kind of go off on your own. So yeah, January 1 will not be a bad idea. Like, I was actually thinking I might do another t-shirt giveaway at 30,000, but I think we are well short of that. What are we at the moment? 29,576. So when we hit 30,000, pop on over, and then we'll actually do another t-shirt giveaway. But if not, all the best, guys. And I know this is a bit of a unique little group that I've got here, because I think you guys all started in during the pandemic, when you guys were all level 1s in pandemic, and you kind of made through this all the way to year 13. So that's pretty awesome. And I think if you're here working away, just keep going, man. Like, keep pursuing your goals. But yeah, all the best, and I'll give you guys my final little message on Instagram tomorrow, and then yeah, I'll just get in touch when you can. And if you see me in public, like, I'll probably be wearing like some sort of Marvel t-shirt, or no, driving a taxi. Douglas, there you go, mate. No, I was actually thinking about doing Uber for a change, but no, I'm quite happy just doing this. Yeah, I'm sorry I couldn't get through all the comments, guys, but I do come and visit Auckland Uni. Like I went and visited some projects this year, so it was pretty cool. I'm down in what do you call it? Down here in South Auckland, man. Like I don't Boxy, you can't do that. You can't actually do it. You just it just solves you the gradient. I teach at Ormiston Junior College, guys. So it's I used to be at senior, but oh yeah, I'm visiting AUT as well. I come and visit a few people there every now and then. But next year, what I'll do is like if I ever come down to uni for any reason, I'll put an early story up. Um, it's pretty good, Finn. I would recommend any place for engineering, man. Like Skylar, I've thought about it, like doing a little road trip. Just come down. I know I'm coming down to Wellington and during when your exam results are out. Um, Ashwin, yeah, I've come down. I came to Christchurch last year for a visit, and I visited a few schools there. Um, that would be hilarious, Tom. Absolutely hilarious. Like I have to say. Now I'm coming down to Wellington. I come down to Wellington in like January, mid-January. I think I'm coming to Wellington. Beaners, I'll see you next year, man. Like we're gonna be doing mathdemic for level 3 differentiation and level 3 integration. Burnside, I don't know. Did I visit Burnside? No, I didn't visit Burnside. I came down to a few places there. Yeah, some of my old mates used to be working at Burnside High School, so. But anyway, guys, look, thank you so much for all your kind of words to kind of keep pushing me to do this, because it's like every year I think this is the last year I'm going to do this. This is the last year I'm going to do this. But just kind of hearing some of the things from you guys, and you know, I have to say big ups to my wife, because she always like, oh look, just go and help these guys out. They're gonna need your help. You know, if you ever want to mention like a person that's like super supportive, that's kind of like my wife. You know, she just pushes me. So anyway, I'm gonna leave you guys to it. You got your last bit of revision to go through. It's been a pleasure to have you guys over the last 3 years. Next year, you know, if you do see me running the streams, pop down, say hello, tell these year 13s and year 11s who'll be like panicking, let them know that it's gonna be okay, all right? And you're gonna laugh. I mean, by the time, I guarantee it, next year at this time, you're gonna be like, I can't believe I was actually stressing about level 3 calculus. It's yeah, that's what you're gonna be like. You're gonna be like, that was pretty easy. So all the best from me, and like I said, don't be strangers, and I will see you guys signing out. And I guess I have to say this, as always, thank you for watching. Good luck tomorrow.